All right, welcome to Online Maths TV. Here we are again, and my name remains Jakes Anemo, in case you thought I forgot my name. Again, we have a challenge on the board, and it's an exponential equation. The question is very simple, but there's a reason why I decided to bring this challenge. So, the reason why I decided to bring this challenge is this. Now, the question is x to the power of 2 equal to x to the power of 2x plus 1. What then will be the possible value of x, or the possible values of x? Now, if you look at this equation carefully, because the bases are the same, you can strike out this. Or, since the bases are the same, it also means that the exponent will be equal. In other words, we can equate this to this. Okay? If you do that, you are going to come up with only two solutions. But here we have about 3 solutions to this equation. So how do we get the 3? The number 1 equation is 1. How do we get that 1 is the reason for this video tutorial. Okay, so let's take down our question. But before we go into that, if you're new to this channel, this is Online Maths TV, where we learn mathematics all the time. If you're new here, do not forget to subscribe. Hit the subscribe button, and when you do that, turn on the bell notification button so that you get notified whenever we drop an amazing video like the one you're about to watch right now. Because at Online Maths TV, we drop wonderful videos all the time without much waste of time. Let's go down to our question here. So here we take our selection. The question is x to the power of x all squared, then equal to your x to the power of 2x plus 1. Now, like I said earlier, since the base are the same, then we can say x squared equal to 2x. But you discover that 1 is one of the roots to this exponential equation. So how do we get that 1? Now, this is what you do, or this is the first assumption. The coefficient of x here is 1, and the coefficient of x here is 1. So definitely, the number 1 root to this exponential challenge is 1. But if you doubt that theory doesn't hold water, then let's prove it from this solving. Look at the method I want to apply here now. Easy. So here, move this right hand quantity to this left hand side. So this will now give us here x to the power of x all squared minus your x to the power of 2x plus 1 equal to 0. Easy. What we do here is to factor out x to the power of 2x plus 1. We could as well factor out x to the power of 2 here. But let's factor out this. So if we do that, this will now give us x to the power of 2x plus 1 then into. If we use this to divide this, since the bases are the same, what happens? We subtract the exponent. And so here we'll be left with x all to the power of your x squared, then minus your 2x, then minus 1. Okay? Then if we use this to divide this, then we're going to come up with minus 1. We'll be left with 1 on this other side. Okay? So from here, we close our bracket. This is equal to 0. Now, if you look at this, we are having this multiply this. But let me put this in brackets so that we don't get confused. So since we are having this into this equal to 0, what we do? We resolve, or we succumb to the zero product rule, which says that if you have your a dot b equal to 0, this implies that your a equal to 0 or your b equal to 0. So if we succumb to that rule, we can equate this to 0 and equate this to 0. So this thus implies that your x to the power of 2x plus 1 equal to 0, or your x to the power of x squared minus your 2x then minus 1 equal to 0. Good. So we now have 2 equations here now. Look at these first ones. For your case 1 here, this does not have a solution. Okay, so there's no solution for case 1 here. For your x to the power of 2x plus 1 equal to 0. There is no number you're going to put in place of x that is going to give us 0 here. All right, so with that, we're taking case 2. So let's take our case 2. So from here, let's erase this and take our case 2. Good. So case 2 here, which is your x to the power of x r squared minus your 2x, then minus 1 minus, sorry, here we're supposed to have here to be minus 1. Oh, please, pardon me. Here we have our minus 1 here, please. Okay. All right, so pardon me on this. So here, minus 1 equal to 0. Very easy. So what we do here, we send this, your minus 1 to this side of the equation. So if we do that, we're going to have this to be x to the power of x squared minus 2x minus 1 equal to positive 1. What we do, again, we take the log to base 10, or we take the natural log, which is your ln base e. So if we ln both sides of the equation, we're going to have here ln of bracket your x to the power of x squared minus 2x minus 1. Okay, but let's put this in bracket. Okay, no need to do that. Okay, so equal to, sorry, bracket, yeah, equal to your ln of your 1. Now, you know ln of 1 is 0. And at the same time, this is another exponent. So we resort to our law of logarithm, which says that if you have log your, let's say, p to the power of k, move this guy backward to give us here your k dot log your p. Okay? So if we succumb to this rule here, then we cannot rewrite everything here. And mind you, ln of 1 is 0. So this will now give us here your x the squared minus 2x minus 1 or into the ln of x bracket close equal to 0. Again, we succumb to the zero product law, which what we did here, we cannot equate this to 0, equate this to 0. So let's take our case 1. We have here, let's take the first one, ln of your x. Okay, ln of your x equal to 0, or your x squared minus 2x minus 1 equal to 0. Easy. Okay, now what we do here, because we are looking for x, we introduce our e. Let's raise this to e, then raise this to e. So our case 1, let's take case 1 from here. Case 1 will give us here your e. Let's take here e to your ln of your x, okay, they're equal to your e naught. So if you look at this, this we go with this. So we're going to have our x equals to what of our e naught? E naught will give us 1. So we have here 1. Okay, so this is the value for our x1. So you now see the picture is now clear. As at when I said, so long the bases are the same, so one of the roots is going to be 1. So if you do not succumb to that theorem, then I've proven to you that 1 is one of the roots to our exponential equation. So we now have case 2, which is your x squared minus 2x minus 1. So how do we solve for this now? Let's continue on this side again. Good. So let's take our equation, which is your x to the power of 2 minus 2x minus 1 equal to 0. Now, we cannot use the factorization method to solve this. So what we do here, we succumb to the quadratic formula, okay? Quadratic formula, right? Yeah, so let's use quadratic formula to solve this. So the formula says your x equal to your minus b plus minus the square root of your b squared minus, minus 4ac, okay? Everything all over your 2a, where our a is equal to 1, b is equal to minus 2, and c is equal to minus 1. So let's go ahead and substitute these values into our formula. So we're going to have our x equal to, here we have minus bracket minus 2 close bracket plus minus the square root of your minus 2r squared minus 4 times our a is 1. This is times, please. There times our c is minus 1. Okay, all over your 2 into 1. So if we carry out our operation, we're going to have this to be a positive 2 plus minus, okay, the square root 4, then minus times minus will give us plus, then 4 times 1 will give us 4. All right, then everything here all over your 2. Easy. Okay, what we do here, we cannot add these two together. So if we do this, we're going to have your x equal to your 2 plus minus the square root of your 8 all over your 2. Good. Now 8 can be split into, if you have your 8 is equal to your 4 times 2, and the square root of 4 is 2. So we can rewrite this to give us here your x equal to your 2 plus minus your 2 into the square root of 2 all over 2. Here we have 2, here we have 2, here we have 2. So we can factor out 2 from here. So our equation will now becomes, let's continue on this side of the board. So if we factor out 2, so we're going to have your x is equal to 2 into your 1 plus the square root of 2 close bracket all over 2. This 2 goes with this 2. All right, so we now have two solutions from here now, which is plus 1 plus the square root of 2 and 1 minus the square root of 2. So in all, we have three solutions from this our exponential equation. So we can now say, therefore, our x1 is equal to 1. Then our x2 is equal to 1 plus the square root of 2. And our x3 is equal to 1 minus the square root of 2. So these are the three roots to our exponential equation. Okay, QED. All right. So this marks the end to this exponential equation. If you learned something from this video, give the video a thumbs up. And do not forget to share this wonderful knowledge with your friends, with your family members, with your students, those you know that need this knowledge. All right. Thank you for always be there. This is Online Maths TV once again, and my name remains Jakes Anemo, your favorite tutor, I guess. Remember, I love you, and every one of us at Online Maths TV loves you because you're always there. Bye for now.